So when there is a change in the air gap, that is a small Lg, there is a change in the inductance, self inductance, and the change. So when the air gap increases, inductance reduces. When the air gap reduces, inductance increases. That can be seen as an induced EMF across the coil, and that can be measured. Okay, and further you can calibrate it with respect to the displacement. Okay. And another is a differential type of an output. So what is the differential type of an output? So you have two different a coil with a differential output, and the changing in the differential output will provide you better results. So what are those better results? The sensitivity to accuracy can be increased. Output is less affected by external magnetic field, because when you are having a differential output, the external magnetic field tends to cancel out each other, just like how we have discussed in instrumentation amplifier. The effective variation due to temperature also reduced. Same, there is a change in the temperature gets cancelled out if there is a differential output, because same outputs comes out of the difference, and they get differenced and they get cancelled out each other. Okay, and the effects of supply voltage and frequency are also reduced. So what is this? So you see here there is a pointer in middle, and this pointer moves in both the direction, and the change in the inductance, because of this pointer, can be measured as the difference between the L1 and L2. Similarly, here what is the concept they have taken? Number of turns. So number of turns changes, the differential output, differential inductance output also changes. Okay. And here comes our mutual inductance. So what is mutual inductance that we saw, guys? So mutual inductance is a change in the current in a given coil produces changes in the magnetic flux, and this change in the magnetic flux will induce an EMF in another coil and results in a current. So that is called mutual inductance from one coil to another. Okay, so now what we will see, you have two cores here, okay, ferromagnetic cores, and here is the iron core that's going to make a movement between this air gap, and these two cores are serially connected. Okay, they are connected serially, and what happens is, when there is so they are serially connected, and these two cores have magnetic flux lines, and when there is a change in the so what happens when there is a change in the magnetic reluctance path, which is produced by the movement of the iron rod, and there is also, you should also remember that permeability also gets affected. Okay, this rod is between, if this rod is more closer to this, there is a permeability changed, there is a closer permeability to L2, but there is a reduced permeability in L1. Okay, so when there so because of that, one will have more inductance, another will have less inductance. Okay, and how this inductance are produced? Because the magnetic flux lines getting affected, and an EMF is induced in the coil. Okay, you should also see that since there is two coils, there is a possibility that this coil might induce an EMF in this coil will induce an EMF in that coil. So that EMF induced in the coil can be written as M. So the range of self-inductance arrange varies from L1, the net effective inductance changes from L1 plus L2, because they are in seriously connected, plus 2M to minus 2M. Okay, the similar arrangement can be seen even for what is that, an angular orientation. So this is a linear displacement. Here we can also see for angular displacement. Okay, so what it can be said is, see, the one coil is fixed, the other coil is made to rotate by the input angular displacement. Self-inductance of the coil is constant, but the mutual inductance between the coil varies on an theta, in the angle of theta. The coefficient of coupling is proportional to cos theta when the axis is of the two or coincide, the mutual inductance is maximum, and between the coils is theta. This can be given by M cos theta. M is the maximum value of self inductance, and it varies between these two values. Okay, and as the above, as it can be seen that in both the cases, they work on geometric path. That is, what is the geometric path? Geometric path is L and A. Okay, so which in turn affects reluctance, and that is going to change your what? Magnetic, that is going to change your self inductance. Okay, and if you take this, the same arrangement is kept. So here the range is limited, but here you can have more number of range. Okay, because there is no obstruction here, you can have more operating range for this for this kind of an arrangement of the transducer, which we will see in the next video.